Hello, Sivaraman. Hello, Sivaraman. Shall we start the class?
Hello, sir. Yes, sir.
Hi, good evening.
Good evening, sir.
How are you?
Yes, I'm fine, sir.
Okay, then. This is the last lecture, right?
Yes, sir.
Mm. So, okay, my name is Anik Kumar Sharma. I'm a pmrf research scholar from IIT Kharagpur, and this is the last lecture of the nptel course Traction Engineering by Professor Ibjur Rahman. Last doubt solving session, and in this session we will discuss all the previous week's things like we will give a summary of I will give a summary of week 1 to 3, 4, 5, 6, and 7. Then uh, lecture 37, 38, 39, and 40 we will solve. So this recap I have given many times. So today I am showing you all the PPTs, and I'll check that how much things you have remembered. So this is week 1 presentation. So if there is any MCQ, then I will ask you. I think this is easy. Which are the following sentence can be used correct? These are things is easy. In week 2, traction. Okay, what is the answer of this question? In the case of a towed wheel, which of the following expression is valid? Do you remember, Sivaram? As this is the last lecture, so I'm just giving a recap. In case of towed wheel, which of the following expression is valid? Do you remember, Sivaram? Any guessing? In case of towed wheel, weight is acting, towed force is there, and torque is zero. This towed force is being balanced. This towed force is balancing the rolling resistance, and ground reaction is acting. If R is the ground reaction, then This is RNH RN3. See what I mean? In case of toad wheel,
Yes, sir.
which option is correct? Toad force is being balanced by the horizontal component of the ground reaction, RNH. TF is equal to RNH. Do you remember these concepts? I think you have forgot.
I need to revise those once again.
That's why means for revision only I am just telling you the asking you the questions. You revise here, no issue. You just try to solve with me. This is numerical. We will leave. In case of self-propelled wheel, which of the following expression is valid? Do you want to solve or we shall move? In case of self-propelled wheel. Okay, you just tell me the concept of self-propelled wheel. What is a self-propelled wheel? What is a self-propelled wheel? I'm asking you just orally. If you are being asked that what is self-propelled wheel, what will you answer?
The self-wheel can produce its own torque, sir.
A self-propelled wheel is a wheel in which there is no pull. Means without pull, just torque is being given to it. Means power is being given to the wheel, and there is no pull attached in the wheel. That is self-propelled wheel. And what is the driving wheel or powered wheel? Driving wheel or powered wheel. The pull is attached to the wheel, and that is powered. That is a driving wheel. Means pull is also there, and torque is also there. That is a powered wheel. Okay, solve this question just for a revision. Which in the diagram shown below, it is all the graphs are versus slip. So this is on the y-axis in this graph. What is y-axis on this graph? What is y-axis on this graph? And what is y-axis on this graph? This I've explained means I've given many given a means elaborative explanation of these things.
Option C, sir.
First is rolling resistance, second is net traction coefficient, third is ductility resistance. Yes, this this thing you can. Do you want to solve? Okay, let's move. Interest and resistance. This is also simple system. Marky things you will solve. Okay, what is in this equation? Which of the following correct equation?
Option D, sir.
K is Kc by B plus K5. This thing we have solved. Okay. In week 3, what we saw, the rolling resistance of a rigid toad wheel does not depend on which of the following. This question I told you that it is wrongly framed actually means as contact area diameter will increase, contact area will also increase. Area of the contact I said the answer, but diameter and area is the same thing. Then Rolling resistance of rigid wheel is directly proportional to which of the following? Do you remember this?
Yes, sir. Diameter of the wheel, sir.
Let me check. Rolling resistance is directly proportional to the weight coming on it. This equation this expression I told you in this lecture means it was R is bk by n plus 1 3w by bk root 2 r 3 minus n some power 2n plus 1. Then if we break this n component and we will separate all the b, k and everything, it is negative power, k is also negative power, 2r which you said diameter is also negative power, weight coming on this on the wheel is in positive power. So this whole thing is diminishing the rolling resistance. If we increase the diameter, it will decrease rolling resistance. And B is in our control. Yes, if we increase B, then it will decrease rolling resistance. If we increase W, then it will increase the rolling resistance. So vertical load coming on the wheel. Then for a given solve condition, in case of rigid toed wheel, this will be resistance of pneumatic wheel is due to on the okay. This you tell. If PG is the average ground pressure, PI is in the inflation pressure, and PC is the carcass pressure. Then PI plus PC, which of the following is elastic mode? It will be greater than or less than or equal. Which will be elastic mode condition?
PG should be greater than PI plus PC, sir.
Which option?
Option C, sir.
Option C means PG is greater than it is elastic mode. Yes, correct. For the same modulus and same. This also I have explained it. Do you remember? If you don't remember, you can leave this question. Then numericals. Then in this fourth week, we discussed numerical. Okay. Wismer and Luth. How many parameters did he choose? Did he take for developing the tractive performance model? Okay, tell me this. Tell me answer of this question. Number of parameters used by Wismer and Luth. Tell me any answer, then we will move to the next question. And
It's
today's
9, sir.
yes, 9 is correct. Which of the following dimensionless ratio was not taken by Wismer and Luth? It was del by h. Which of the following is not a limitation taken by Wismer and Luth? Cone index. This I've explained. Okay, tell me the rolling resistance formula of Wismer and Luth.
Option A, sir.
Correct. Mu gross traction ratio formula. Option C. Brixius, he took 11 parameters. Which of the following parameter was not taken? This thing we have seen in the previous question. Ratio of rho R by D. Do you remember the ratio? I think it is 0.474. Yes. Okay. Mobility number. This you have to remember all the time. Which is correct? Sivaraman?
Option D. Option D, sir.
Yes, yes, correct. Motion resistance ratio of bricks.
Option D, sir.
Yes. And this gross traction ratio. Which option?
This is option D, sir.
Yes. 100% correct. With an increase in tire diameter, the coefficient of traction.
Increases.
Correct. For the same diameter and same width of single and dual tire will perform better.
Perform better.
Mm. This is the last class. Which of the following methods are generally used as traction aid for dryland? Chains, yes, for dryland. Cage wheel is for wetland. Sticks for wetland. Tracks for lasting. A, D, E. Hmm. Answer this question. This I explained last Saturday. This is optimal ballasting or under ballasting or over ballasting. First curve.
Under balancing, sir.
This is this is over ballasting. This is optimal ballasting, and this is under ballasting. Regarding this, we also solved a numerical in which we saw how this curve has been plotted in this equation. These all curves we obtained last week. Okay. Which of the following is the expression known as Dryer's equation for optimal ballasting?
Option C, sir.
Hmm, correct. Okay, so we have given a summary. We did a revision, and then today we will see the lateral force, coordinating stiffness, mainly the stability of the vehicle while steering. We will see in this week. Which of the following is expression correct? Which of the following expression correctly represents the relation between coefficient of lateral force and slip angle? Have you seen the lecture?
No, sir. I didn't see it, sir.
Okay. Okay, then you will not able to answer. You just guess which of the following can be a correct option.
Option C, sir.
Option C, yes. Option C, not option C, no. Option A is the correct option. Where CLF is the coefficient of lateral force, alpha is the slip angle, A and B are constants. So if this is a wheel, suppose it is turning, some force is acting on is acting perpendicular to this wheel. This force is rolling resistance force. This force is lateral force. This force always acts. So this thing we will discuss in this lecture. And this coefficient of lateral force has this relation. So first you see, if a vehicle is moving, then it has three motion in the three plane. So do you have any idea which in x direction the velocity is called what? If this vehicle will suppose turn in this direction, then this motion will be called which motion? And if it will turn in this direction, if means it is turning like this vehicle is turning like this, then this motion is called what? And if this vehicle is moving, is turning like this, then this motion is which motion?
Sir, is that option B, sir?
Option D.
B, sir.
B means first is roll. Option A, if this is rolling, this is this is not rolling. This is rolling.
Okay, sir.
Means B is rolling. This one is Z is yaw. In Z direction, this the turning is called yaw motion. And if the vehicle is moving in this direction, is turning in this direction, then it is rolling. And if it is doing like this, then it is pitch motion. Means A is pitch, second is roll, C is yaw motion. Understood?
Yes, sir.
Okay. Which of the following is correct expression relating steer angle, track width, and wheel base? Or you can also say which of the following is the correct expression for the perfect steering. If the vehicle is steering, then which expression defines the correct steering?
Instead of Ricky said,
Wait. T is track width. So this is T or B. Which is track width? This one or this one? B is wheelbase. You tell me this red color or maroon color is wheelbase or track width. And this blue color is wheelbase or track width.
it's a maroon color track with
Which one?
it's a maroon color track with
Track width means T, yes. And this is wheelbase B. Yes, you are correct. This is the front, this is front wheel, this two, and this is the inner front wheel, means the vehicle is turning in this direction. So this one is delta and this one is delta O. So delta I is major steer angle because it is larger. This theta is larger. This is minor steer angle. We have to find the expression between between delta I, delta O, T and B. So suppose this distance means radius of turning uh, means center where the where the curve is being formed. This center distance to the inner wheel distance is x. Then what will be called delta? Cot delta I mm, means simple mathematical expression. Cot del I is this is our b and this is x. So cot del I is cot theta. This we have studied in class 10. Cot theta is Sivaraman. B by h. If this is b and this is h, this is theta. Tan theta will be height by base. Cot theta is base by height. So this is base is x and height is b, x by b. Again, cot delta O. Cot del O is, for cot delta O, what will be the base? For this triangle. For cot delta O, you see this triangle. And tell me what is cot delta O. This is delta O. In mathematics, we write height as perpendicular, means p by b. Sivaraman,
express the X plus T by B answer.
X plus t by v.
B.
Hmm. Now cot delta I minus cot delta O is equal to x by b minus x plus t by b. This is equal to
Minus T by B.
minus t by b. Now you do minus sign to, you send minus to this side. So this will become cot delta O minus cot delta I is equal to t by b. Means cot delta O minus cot delta I is t by b. Cot delta O minus cot delta I is t by b. Understood?
Yes, sir.
This is for perfect steering condition. Now the vehicle is not will not always go perfectly because uh, some lateral force acts on this on the wheel. Suppose this is the inner wheel which we have drawn, means the first wheel we are omitting right now. This is center of gravity. So while turning, this is the center line of the wheel. So this is the steer angle delta F. This is R, and uh, in the first slide what I said is there always acts some lateral force which is denoted by Fs, lateral force, suppose L, and this is rolling resistance force, suppose Fr. So this will give a resultant force in this direction. This resultant force will make some angle uh, with the line of motion of the wheel, and this angle is called alpha F, and this is called slip angle. So the question is, which of the following is the correct expression relating steer angle and slip angle of front and rear wheel? The same thing you imagine for rear wheel. Then if you have not seen the lecture, then you can only guess, but I will explain you how this expression came. So this thing you have you understood what is slip angle, what is steer angle. Sivarma,
Sir,
what is slip? The difference of slip angle and steer angle. Have you understood? This is wheelbase L. This is L. This is R. Radius of curvature. So if you suppose this as an arc, then this L by R will be given by alpha F plus beta plus del F minus alpha F minus beta. this beta beta coefficient and L H is equal to L by R minus alpha R plus alpha F. So mainly you have to understand what is alpha R and what is alpha F. Did you understood what is alpha F? This is slip angle of front wheel, and alpha R is slip angle of rear wheel. Sivarman, have you understood what is slip angle?
So can you say the third one thing, sir?
There always acts some lateral force on the wheel perpendicular to the center line of the wheel. Along the line of wheel, the force is rolling resistance force, and this is lateral force. So this force will give a resultant force. Suppose this is the resultant, and due to this, there it will create a slip angle. Means this resultant, the direction means the angle of this resultant with the line of motion is slip angle, and the the center line of the wheel will make uh, an angle with the line of motion of the wheel, and that angle is a steer angle, delta F. In the previous slide, what we discussed is the steer angle. Now we are discussing the relation with the slip angle. So this equation we will get when we will do the geometry of this whole arc and all. We will get this equation, and when you will balance the moment, this W V square by GR. This is centrifugal force uh, acting on the wheel, acting on the tractor or any vehicle. If you will balance whole this equation, then you will get this F. This suppose this is lateral force on rear wheel. This is lateral force on front wheel. Then F as rear will be given by some cornering stiffness C alpha R into, it will have a relation with the angle, means the slip angle of the rear wheel, alpha R. And the for front wheel, F as F, cornering stiffness of the front wheel into alpha F. This will be the formula. So when you will see the lecture, you will get, means this is a long derivation. That's why I'm skipping this. You will get an expression of FSF and FSR. That I will just write here. This FSF or FSR you will get as WF V square by 2GR. For rear wheel, it is WR, means weight coming on the rear wheel, into velocity by 2G is the acceleration due to gravity, and R is the radius of curvature. For front wheel, you will get the lateral force on the front wheel. The equation will be WF, means weight coming on the front wheel, into velocity square by 2GR. From this equation, you can get alpha R and alpha F. Alpha R will be this equation divided by C alpha R, and alpha F will be this equation divided by C alpha F. This is alpha R, this is alpha F. You put this alpha R and alpha F in this equation, the final expression will be delta F is equal to L by R minus wf v square by 2gr cr c alpha r plus wf v square by 2gr c alpha f. Sivaraman, are you getting?
Yes, sir.
Okay. You take this v square by 2gr common, then what you will get is l by r. Then what you will get is delta f is equal to l by r minus v square by gr wf by c alpha r minus wf by c alpha f. This expression is called understeer coefficient. Understeer coefficient or KUS. This decides the vehicle is understeered or oversteered or neutral steered. This expression will decide. So, if which of the following is the case of neutral steer? As you have not seen the lecture, so you can from from whatever thing I've just said, you can guess that what can be neutral steer. In case of neutral steer, what will happen to this equation? If this is understeer coefficient, then which of the following is case of neutral steer? What is your answer?
Option C, sir.
Yes, this is correct. In understeer coefficient will be equal to 0. Means this equation will be 0. This will be equal to this. This W by C alpha weight by according stiffness of front and rear will become equal, and this will be a neutral steer. I will explain what is neutral steer, what is oversteer, what is understeer. Suppose this is the vehicle. It is making a turn. If the turn is smooth, then it is neutral steer. Here KUS will be equal to 0. If it is in understeer condition, the vehicle will move away from the axis. Means this is suppose R. Then R will be greater for this understeer condition. In understeer condition, vehicle moves away from the center of the movement or center of curvature. This vehicle will move outward in outward direction. Here KUS is negative, and in understeer condition, sorry, oversteer condition, oversteer condition where the driver has moved the vehicle too much inward. Means that was not required, and means driver has moved the steering angle too much. Then this is oversteer condition, and KUS will be positive in this case. So this can be more clear when we will solve two, three questions. Then this can be more clear. It will become this practical based question. So the first question is: a 616 tire has a cornering stiffness of this much Newton per radian, a camber stiffness of this much Newton per radian. The camber angle at which the tire is fitted to the axle is 4 degree if both the cornering force and camber thrust are acting in the same direction and are linearly related to slip and camber angle respectively. Then determine the total lateral force. Means on any vehicle, what I said, a lateral force acts, and this, suppose this Fs is acting the lateral force. This is summation of the lateral force due to the cornering stiffness. uh, Cornering stiffness is due to the slip angle alpha, and it is also due to the camber stiffness, which is due to the camber angle. So this is summation of stiffness due to slip angle and stiffness due to camber angle, which can be denoted by gamma. And this is summation of the coefficient C alpha into the angle. If it is slip angle, then alpha, and if it is camber angle, then gamma, means C gamma into gamma. So what you have to do, you have to do the multiplication of cornering stiffness 133.3 kilonewton per radian into the cornering angle is slip angle. Cornering stiffness is due to slip angle, so this will be multiplied by 3 degree. This is due to slip angle, and another lateral force will act due to camber angle, and that will be 2 229 Newton per radian into 4 degree. This is 4 degree is the camber angle. So have you understood this problem and what I just elaborated? Sivaraman?
So can you explain what is in the camber stiffness, sir?
Cornering stiffness is due to slip angle. Slip angle you have understood.
Yes, sir.
When this lateral force and this is the rolling resistance force, this will give a resultant force. This resultant force will make an angle with this uh, vehicle center line. This angle is slip angle. This due to this slip angle, uh, we get a cornering force on this wheel, and due to camber angle we get a camber stiffness on this wheel. That too means the summation of camber stiffness and cornering stiffness gives resultant to gives a force which is lateral force denoted by Fs. You have to just means you can note just that the cornering stiffness and camber stiffness, both force gives resultant to lateral force. And what exactly cornering stiffness is doing, that that I can explain you on WhatsApp. I will see.
Okay.
So you have to do this problem. You solve this and what you tell what is the lateral force you are getting. This is kilonewton per radian. This is in degree. So you convert this degree into radian or this radian into degree. Better you convert this degree into radian. And this is in Newton per radian. You convert this in kilonewton later. Whatever you will get in terms of Newton. This that is the amount of force that which is acting on the which is acting perpendicular to the wheel, and that is lateral force. So this 229 into 4 degree you convert into radian. Do you know how to convert degree into radian? 1 degree is how much radian? Sivaram.
Sir,
180 degrees pi radian. Do you know? This is pi in radian and this is 180 degree. So 180 degrees pi radian. 1 degree is pi by 180.
0.0174.
So 3 degrees 3 pi by 180 in radian. So you multiply 133.3 into 3 pi by 180. This will come kilonewton. Because kilonewton per radian into radian will get cancelled. You will get kilonewton. And this side you do 229 into 4 pi by 180. This you will get in Newton. You multiply by 1 by 1000. You will get in kilonewton. This both you add, you will get what is the lateral force on this vehicle. What answer you got?
6.985 kilonewton, sir.
6.985
985.
kilonewton. This is the lateral force. Now you see the next question. A two-wheel drive tractor has a total weight of 18.2 kilonewton and a wheelbase of 1.85. The static weight distribution in the front and rear axle is 30 and 70%. 75%, sorry, 70%, 30%. And weight is 18.2 kilonewton. Wheelbase is 1.85. If the cornering stiffness of each of the front tire is 38.92 kilonewton, means cornering stiffness is C alpha of front tire is 38.92 and the rear tire C alpha R is 36.25 in kilonewton per radian. Then draw the conclusion for slip angle of the front and rear tire and also turning radius. Means what will happen to this vehicle? It is it will it will have under steer condition or over steer condition. For that you have to find the under steer coefficient, that is KUS, denoted given by expression WF by C alpha F into alpha F, right? So C alpha F minus WF by WR by C alpha R. This is industrial coefficient. So you have to find weight coming on the front wheel, weight coming on the rear wheel. You have to multiply, you have to divide by C alpha and C alpha R. Weight coming on the front wheel is 18.2 into 30%, 0.3 is, is the weight on front axle. Divide by 2, you will get weight coming on the front wheel. So weight coming on the front wheel is 18.2 into 0.3 divided by 2 divided by cornering stiffness of the front wheel, that is 38.92 kilonewton per radian. This is also in kilonewton. This we have written in 18.2 kilonewton. So there is no problem. This minus WR is 18.2 into 70% is going on the rear axle divided by 2 by cornering stiffness of the rear wheel is 36.25. This you do, and if you are getting negative value, then it is understeer. If you are getting positive, then it is oversteer. If it is 0, it will never be 0. If it is 0, then it is neutral condition. So you tell what is it is negative or it is positive, and what is the amount.
So I'm getting the value negative, sir.
What
Minus
were
0. I'm getting the value negative, sir. Minus 0.1056.
0.105? Okay, means this is in understeer condition. Means the driver need to move the steer somewhat more in a direction, then it will become neutral. So this is the conclusion, that the vehicle is in understeer condition. And the second thing is that determine the speed above which the tractor will exhibit directional instability. Means the critical velocity we have to find. Means above that speed the vehicle will be unstable. So formula for critical velocity that I have not given in assignment is root under G into L by, if the vehicle is in understeer condition, then minus KUS, and if it is in oversteer condition, then plus KUS. It is in understeer condition, minus KUS you have to write, and L is the wheelbase, the velocity you will get. Above that velocity you don't need to operate the vehicle. So this is 9.8 into L is 1.85 divided by 0.105. This will be meter per second.
13.14 meter per second, sir.
18.14.
13, 13.4.
Okay. Okay, this I'm not sure that it is in meter per second or kilometer per hour. I will tell you. I will text you.
Okay.
Okay, this is the last problem I think. And this is question number 5. 4. This is 5. This is 6. This is 7. A tractor fitted with 616 tire in the front axle and 13.628 tire in the rear axle has total weight of 2400 kg. With a weight distribution of 35%, 65% front and rear axle. Track width is 1.2 meter. Track width this 1.2 meter. Center of gravity is at a height of 0.8 meter. This tractor is moving across a slopy land 20 degree with horizontal. Suppose this is the land 20 degrees with horizontal. This is suppose the vehicle. This is the front wheel. This will be the bed. This is W. If this is 20 degree, then this is W cos 20. This is W sin 20. So cornering stiffness and camber stiffness for front tire is given. For rear tire, the lateral force is due to cornering stiffness only. The camber angle at which the tire is fitted to the front axle is 4 degree. If both the cornering force and camber thrust are acting in the same direction and are linearly related to slip and camber angle respectively with the wheel slip angle of 4 degree for front tire and 3 degree for rear tire, then verify whether the tractor is stable during operation against overturning and sliding. So overturning, the critical condition or the condition for overturning is first you have to check it is stable for overturning or not. Then second you have to check it is stable for sliding or not. For overturning the condition is tan beta. If this tan beta is greater than track width by 2 into center of gravity of the ground from the ground, center of gravity from ground, or if it is denoted by L, then this tan beta, if it is greater than 2 by T by 2L 2H, then this will overturn. So that you have to check. Means tan beta is this angle 20 degree. Then 20 degree you find. Then track width is 1.2 meter. 1.2 by 2 into center of gravity is at a distance from the ground, center of gravity height of 0.8 meter. This first you check, then you will get that it will overturn or not. This 10-20 degrees. 10-20 degrees.
0.3639.
0.36. Okay. And this 1.2 by 2 into 0.8 is
0.75, sir. 75.
0.75. So this tan beta is not greater than 0.75. This tan beta is smaller, means the vehicle is safe for overturning. So did you now you can you find that the vehicle is is stable for overturning or not? Overturning condition, did you understood? You have to just check this condition. Tan beta should be, if tan beta is greater than 3 track width by 2 into center of gravity from the ground, then this will overturn. This is just this is simple. You can remember this. So now we will check for sliding. For overturning it is safe. Now we will check for sliding. So for sliding, what we need to do is here the role of that lateral force will come. Lateral force means the force which is perpendicular, acting perpendicular to this wheel. This is lateral force according to definition. So this lateral force is on rear wheel also and front wheel also. And according to question, this the lateral force due to on the rear axle is only due to the camber angle. The front tire has coronary stiffness and camber stiffness. Means the lateral force on front tire is due to slip angle or coronary stiffness and due to camber angle, camber stiffness, both camber stiffness and coronary stiffness. This two will add to lateral force of front wheel and the camber angle at which the tire is fitted to the front axle. And for the rear axle, can you notice the rear tire has a cornering stiffness of 90 kN. It has just a cornering stiffness, not camber stiffness. Means, can you do you understand this line? The front wheel has a camber angle. Do you remember the steering theory of BTEC? Front wheel has a camber angle. What is camber angle? Sivaraman, this is a tire. If you are viewing it from front, then this is the vertical plane. This is the center line of the tire. But it is not like this. The front tire is given some has is always given some camber angle. This gamma for better steering. So due to this camber stiffness comes and this camber stiffness gives rise to the lateral force. That is not in the case of rear wheel. In rear wheel we don't give any camber angle. In rear wheel is simply a straight when you will see it from vertical. But when you see the front wheel from the front wheel from the means front plane, then you will find that it is at an angle with the vertical axis. That angle is only in case of front wheel. So the lateral force on the front wheel is due to camber stiffness and this cornering stiffness. And in case of rear wheel, it is only due to the cornering stiffness or the slip angle. So again, you have to do the same cornering stiffness into means coefficient of cornering stiffness C alpha for rear wheel into alpha slip angle of rear wheel. This will be the lateral force on rear wheel plus, and for front the lateral force will be due to cornering stiffness, that is C alpha F into cornering stiffness is due to slip angle. This is alpha F plus it is also due to cornering stiffness. Coefficient of cornering stiffness is also due to camber angle into the camber angle or gamma. This is the lateral force on front wheel. When you will do this, you do this summation, then we will proceed. C alpha R. C alpha R is this cornering stiffness of rear wheel, 90 kilonewton per radian. 90 kilonewton per radian. And slip angle of rear wheel is given for rear tire is 3 degree into 3 degree. Again you convert it into radian. This will be the lateral force of rear wheel. For front wheel C alpha F, cornering stiffness is 133 kilonewton. 133 kilonewton per radian into front wheel has a slip angle of 4 degree. Then this you add this you add with uh, camber angle. This is camber stiffness is 2 to 9 Newton. This is Newton. Newton per radian into camber angle is 4 degree. Camber angle of front wheel is 4 degree. You do this summation, add this one, and this one. This then you will get the total lateral force on this of this vehicle. This is in degree. This is kilonewton per radian. This is kilonewton per radian in degree. Multiply, do everything in radian. This is Newton. Just you convert it in kilonewton. You do this sum.
Sir, I got the final value as 14.034, sir.
14.034 kilonewton. Okay. This is the lateral force. Means this lateral force is acting on this tractor. Now, what is the opposing force? Means this W sine beta. This you find. If this W sine beta will be greater, then it will slide. W sine beta means W is true 2400 kg. 2400 kg means 9.8 by 1000. This is kilonewton into sine 20 degree. What is this kilonewton? 2.4 into 9.8 sine 20.
8.04, sir.
8.04. This 8.04 is acting in this direction. 8.04 kilonewton. And this 14.034 is acting in this direction. So will it slide? Will this tractor slide?
No, sir.
Hmm. That is the question. So have you understood how it will slide, what slide overturning and sliding problem?
Yes.
Hmm. I think your doubt for lateral force is clear now. Should be clear now. Do you want to ask anything? How is your weekly assignments going?
Yes, sir, I did well, sir.
So that you will do after 2 3 days. What assignment you will do? That will be your last assignment.
Yes, sir. Uh,
Okay. Is there any doubt in the assignment? Is any query or any question is confusing? And some anything like that?
No, sir.
Okay, then we will end the class. If you have any doubt, you can contact me anytime regarding traction engineering. Now you are doing what? Means you have completed your masters, no?
No, sir. Uh, I'm currently pursuing my BE in agriculture engineering, sir.
Sorry, what you are doing?
BE in agriculture engineering, sir. Engineering, sir.
Okay,
I'm bachelor student, sir. It's my final year.
okay. From Engrau, right?
Sir,
From Engrau, na? Which university?
I'm from Tamil Nadu, sir. Anna University.
Okay, okay. So after this BTech, are you thinking of coming to miss you? Will you give gate? Do you have
No,
gate
sir, but
examination
I
in?
didn't do. I didn't attend this time, sir. But I have the idea of getting attending it next year, sir.
Sorry, what you will do?
I'm in idea of attending it next year, sir. I with I'm in idea of I'm in idea of preparing this 1 year, sir. So after preparing for the gate examination.